So as mentioned previously in another video, when a power series converges, it'll converge to a function, and then we can use it to approximate the function. We're interested in finding exactly where a power series converges. So for a given power series, we're interested in the values of x where the series converges. This will be called the interval of convergence, and another measure of convergence is called the radius of convergence, and this is just the distance from the center A to the boundary of convergence. So I pictured the interval, what the interval of convergence represents here, and then the radius of convergence is just the distance from A to the edge of the interval of convergence. To find the radius and interval of convergence, we'll need to do two things. So the first, so typically we'll use the ratio or the root test, and then this will be used to compute the appropriate limit, and then from the limit we'll find the values of x where this limit is less than 1. So the reason we take less than 1 is because this is where the ratio and the root test converge. And then the second step will be to check to endpoints whether they converge or not by plugging in the endpoints in for x and then using the appropriate test. Okay, so as a first example, let's take a look at the power series sum k equals 0 to infinity of x to the k over k factorial. Because the series contains k factorial, we choose the ratio test instead of the root test. So the ratio test is to compute the following limit, to the limit as k goes to infinity of ak plus 1 over ak. So we'll take the absolute value to check for absolute convergence, which will make things a little bit easier. Okay, so now let's compute this limit. So this is the limit as k goes to infinity of x to the k plus 1 over k plus 1 factorial over x to the k over k factorial. And then this becomes the limit as k goes to infinity. So let's rewrite this fraction. So as x to the k plus 1. So let's use the formula to simplify the factorial. So that's k plus 1 times k factorial. And we multiply the reciprocal of the denominator. So this is k factorial over x to the k. So now the k factorials cancel out, and then the x's also simplify. So this is the limit as k goes to infinity. So we have x in the numerator, and then k plus 1 in the denominator. And we can separate the absolute values. And so we can pull the x out because the limit is in terms of k. So this is the limit as k goes to infinity of 1 over k plus 1. So the absolute value of x comes out, and then computing this limit as k goes to infinity, this goes to 0. So this absolute value of x times 0, but 0 times anything is equal to 0. So this limit is equal to 0, which is always smaller than 1 for all values of x. So this limit is always smaller than 1 for all values of x, and so the interval of convergence will be all values of x in the real number line, or from minus infinity to infinity. So the radius of convergence is infinity. So then in this particular power series, it will converge for all values of x. So let's take a look at an example where this won't be the case. So let's consider the series sum k equals 1 to infinity of minus 1 to the k times k times x minus 4 to the k over 2 to the k. So first we notice that the center A is equal to 4. Okay, so now first we decide to choose the root or the ratio test. So there's no factorials, and we see the k in the exponent. So let's try the root test. But the ratio test will actually also work for this particular series. But let's try the root test to see how that works. So the root test is a slightly different limit. So we take the limit as k goes to infinity of the kth root of the terms ak. But again, we're going to try to get rid of the minus 1 factor by taking the absolute value to make things slightly easier. Okay, so this limit becomes the limit as k goes to infinity, so the terms ak is what's here. Again, we take the absolute value, so the minus 1 goes away. So we have k times x minus 4 to the k over 2 to the k. So this part, take the absolute value, and then this whole thing, we take the kth root, but the kth root is the same as 1 over k as the exponent. Okay, so now let's simplify this limit. So this is the limit as k goes to infinity. So we distribute the exponent. So this is k to the 1 over k. And then now here the exponents cancel out. So you get x minus 4. And then in the denominator, the k and the 1 over k, again they multiply, so they cancel out. So you're just left with 2. And then now this part doesn't depend on k. So we can pull it out of the limit. So this becomes absolute value of x minus 4 over 2. The limit as k goes to infinity of k to the 1 over k. And then, so this is actually infinity to the 0. So you have to use L'Hopital's rule to compute this limit. This limit will be equal to 1. So you get absolute value of x minus 4 over 2 times 1. So this goes to 1. And again, we want to set the limit less than 1 because that's where the root test converges. So the inequality becomes absolute value of x minus 4 over 2 is less than 1. So simplifying this, we get absolute value of x minus 4 is less than 2. So then we can write this as x minus 4 is between 2 and minus 2. And so adding 4 to both sides, you get 2 is less than x is less than 6. So this is the radius of convergence. And this is the interval of convergence. So again, to visualize it again, the center is at 4, and the edges of the interval are at 2 and 6, and so the radius is equal to 2. Okay, so that's a preliminary analysis of the interval of convergence. So now we want to check the endpoints. So for x, so the endpoints are at 2 and 6, so x equals 2, x equals 6. So we plug it into the original series. So you get the series sum minus 1 to the k, 2 minus 4. I'm missing the k, so then k times 2 minus 4 to the k over 2 to the k. So let's simplify the series. So this is the sum minus 1 to the k. So 2 to the 4 is 2 to the k. The k times it's minus 2 to the k. And the whole thing over to the k. So the 2 to the k's will cancel out. You get a minus 1 to the k. So it's equal to the sum minus 1 to the k times minus 1 to the k. And then the minus 1 times the minus 1 becomes positive 1. So this is the sum k, but this diverges. By the divergence test. So the left endpoint diverges. So let's check the right endpoint. So you plug in x equals 6 into the series, so this becomes the sum minus 1 to the k of k times 6 minus 4 k over 2 to the k. Then this is just the series sum minus 1 to the k k times 2 to the k over 2 to the k. Then this cancels out. Just the series sum minus 1 to k times k. But if you check the alternating series test, you'll see that this series also diverges. So it diverges at both the endpoints, so this really is the interval of convergence. And the radius of convergence is equal to 2.